Welcome back. I'm Preeta Bhattacharya from Bentley Systems. In this video, we will cover the design of slab for an analyzed STAAD file. We will make different settings and set different parameters for slab design. We will save the design output from STAAD Advanced Concrete Design and check what type of outputs are generated. So, let's get started. On this screen, we see a structure in 3D view in STAAD. For this structure, we are going to design the slab at 7.85 by 8 meters. This is the second level of the structure. We are now in STAAD Advanced Concrete Design with the STAAD file already imported. We can see the 7.85 by 8 meter layout on the right hand side of this window. We can save this layout in DXF format. On the left side of the screen, we can see the design data for the slab. The LX and LY are auto-identified. The span type is also identified based on the ratio of LY by LX. The panel type for each slab is auto-identified. It can be changed here as per user requirement. We need to provide the imposed load intensity and the live load intensity now. Let's specify 2 kN per square meter is exclusive of the self weight of the slab and say the live load is 3 and the thickness is auto calculated here. The user can define it manually too. Then we copy and paste these values for all the slabs. If we want the slab to be sunk by 150 mm, we enter minus 150 mm in the top of slab column. For the slab, say if it is a cutoff, then in the drop-down list, we select true. Moving on to settings, we have different ones available for detailing style, the detailing option, different curtailment locations and lengths, diameter settings, the spacing, the concrete and steel grade, the cover setting, and other S by D ratio parameters that we need to set for developing the slab design. We can make the settings in Design Setting window as per desired results. Now, we run this file for performing the design. Before running, STAAD Advanced Concrete Design will ask you to reevaluate the panel type as we have provided sunk for a slab and there is a cutout for a slab. We see the panel type of the slab changes depending on its neighbor slab type. In design output, what are the reports that can be generated? Let's see. The first report is text schedule where STAAD Advanced Concrete Design has generated the text schedule by grouping the similar slabs with thickness and the reinforcement configurations for the bottom and top reinforcement. The general arrangement of top reinforcement is provided. Here we see the top reinforcement layout for the slab. Similarly, for the bottom slab, we see the reinforcement detailing in the plan for each slab. By providing details like the size of the supporting beam and the number of the supporting beam, one can simply generate the slab section for 4 or 5 slabs or any number of slabs which are in continuity. Here, we have generated a section of 4 continuous slabs. We have the general arrangement layout for the slab where STAAD Advanced Concrete Design has generated the supporting beam sizes and numbers. We can also generate the slab design summary for all slabs in a single report and save the reports in HTML format, which can be opened in PDF format also. The detailed design calculations for all the slabs are available. It gives you the general detail, the design moments for which it will design the bending part, the shear check, and the deflection check for each slab performed in STAAD Advanced Concrete Design. The bill of quantities summary for the slab is generated, which provides the consumption of reinforcement, concrete, and gives the shuttering quantity. Here we see a vital feature of STAAD Advanced Concrete Design. We can generate a staircase section for a particular slab by providing the data of the beam and the type of the beam. Now, we generate the bar bending schedule for the top and bottom reinforcement in STAAD Advanced Concrete Design. The bar bending schedule we get for top reinforcement can be saved separately in a DXF format file. For each bar shape, its bar mark, the total quantity of the bar, the length of the bar, and the weight in kg of the bar for top reinforcement is provided. We come to bottom reinforcement now. The bottom reinforcement BBS is also generated separately. A table for BBS is provided similar to the top reinforcement for BBS. For each bar shape, a bar mark and the total quantity of the bottom reinforcement is provided. Further, we can design this particular slab for different types of loading. Simply go to Modify and click on Design, then imply multiple imposed loading here. For instance, we have three types of load. Let's apply uniformly distributed load, point load, and uniformly varying load on the same slab, then design the slab for all three types of load at the same time. We can also change other parameters like the thickness and the cover to get the design. So, we have multiple options of designing as well as detailing any slab after the auto design process is over. For the same slab, we can also detail the slab where we can change the reinforcement diameter as well as spacing for the slab. Once we change any configuration, just go here and click the Accept button. And then the revised reinforcement configuration will be printed over here. We can also copy the entire table and paste it in Excel for further use. That's all for today. In the next video, we will cover designing of the beam by using STAAD Advanced Concrete Design. Thank you for watching.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.